Hello guys, today I'm going to explain the tricks to find out the hybridization of simple inorganic compounds. First of all, what is hybridization? Hybridization is the intermixing of different atomic orbitals to form hybrid orbitals having equal energies. For example, s orbital and p orbital, one s orbital and p orbital hybridized to form this sp hybrid orbital. In fact, this is one hybrid orbital. Here two hybrid orbitals will be formed. The number of atomic orbitals overlap will be equal to the number of hybrid orbitals formed. One s orbital and a two p orbital to form sp2 hybrid orbital, and three sp2 hybrid orbitals will be formed. Similarly, one s and three p atomic orbitals overlap to form four equivalent sp3 hybrid orbitals. This is very important to note here, that the number of hybrid orbitals formed will be equal to the number of atomic orbitals overlapped, etc, etc. Now, the tricks to find out the hybridization of the central atom is, actually there is formula to calculate this, and the formula to calculate hybridization is H is equal to V plus M plus A minus C divided by 2. Now, from hybridization concept, we can know the geometry and the shape of the molecule around the central atom. Now, in this case, V is nothing but V is number of valence electrons of the central atom. M is number of monovalent atoms attached to the central atom. A is anionic charge, and the C is the cationic charge. So in this formula, if the value of H comes out to be 2, then the hybridization will be sp, and if its value is 3, then the hybridization is sp2. 4, hybridization is sp3. 5, the hybridization is sp3d, and for 6, the hybridization is sp3d2, and for 7, the hybridization is sp3d3. Now I'm going to write the geometry and structure of these hybridizations. First of all, for sp, the geometry is, this is the geometry is linear. Structure is something like this. These are the atoms attached to the central atom A, and for sp2 hybridization, the geometry is trigonal planar. Structure is, this is the central atom A, and this is the structure of trigonal planar. Angle between these two hybrid orbitals is 120. This is 180 degree. Now, for sp3 hybridization, the geometry is tetrahedral. and the structure of the triangle is like this. Angle between any two hybrid orbitals, this or this or this or this, is 109.5 degree. Now for sp3d hybridization, the geometry is trigonal bipyramidal, and the structure of trigonal bipyramidal is, this is A, the central atom, this is trigonal planar, trigonal like this, and one bone up and one bone down. These two are called axial bond, and these three which are in plane are called equatorial bond. Angle between an axial and equatorial bond is 90 degree. This is 90 degree, this is 120 degree, and this is 180 degree. So three different angles are here in trigonal bipyramidal: 90, 120, and 180. Now, in case of sp3d2 hybridization, the geometry is octahedral, which is also called square bipyramidal, and the geometry for this octahedral is, this is central atom, draw one square like this, this 3, 4 bones will be on the same plane. This is, for example, one plane, 4 bones will be here, and one bone up and one bone down. These two will be like this. Angle between any axial bone and the equatorial bone is 90 degree. Here this angle is 90 degree, this angle is also 90 degree, and this angle is also 90 degree, not 90 plus 90, 180. This is only 90 degree because this bone is like this. So this is 90 degree, this is also 90 degree. Okay, this is octahedral geometry. And for sp3d3 hybridization, the geometry is trigonal bipyramidal. This is pentagonal bipyramidal, and the pentagonal bipyramidal is, this is the central atom. For example, we draw 5 equatorial bones and 2 axial bones. These 5 will form a pentagon like this. Structure is not so good, but it is pentagon, and the 2 bone will be in axial bone. These are equatorial bones, and the angle between 2 equatorial bond is 72 degree. This is 72 degree, this is 90 degree, this is also 90 degree. So this is pentagonal bipyramidal. Now let us take some examples to know the hybridization geometry and shape. Now shape is different from geometry. Actually, structure represented by lone pair and bone pair is geometry, and the structure represented by bone pair only is shape. This will be clear from this example. First example is very common molecule, water. Here oxygen is the central atom, so applying this formula V, which is the number of valence electrons of the central atom, oxygen here in this case will be 6 monovalent atoms attached to the central atom. This is hydrogen is monovalent, 2 hydrogen atoms, so in place of M there will be 2. No anionic charge, no cationic charge, divided by 2. This will give the value of H as 4. So this implies hybridization is sp3, which again implies geometry is tetrahedral. Now shape will not be equal to tetrahedral. Now let us know the toroidal geometry by oxygen, by drawing the toroidal geometry around the central atom oxygen like this, and only 2 hydrogen atoms are attached on oxygen atom. These 2 hydrogen, these remaining 2 bonds will be converted into lone pair. Now geometry is lone pair, this bone pair, this is bone pair, this is lone pair, this is lone pair. Now this is the geometry represented by lone pair and bone pair. Now what will be the shape? Shape is represented by the bone pair only. So what is the structure of water here without the lone pair? Only bone pair. This is angular or V shape or band. So shape of water will be angular or band, you can say. Now let us take another example. Second example is for example PCl5. Now in case of PCl5, phosphorus is the central atom. So applying this formula again, V is the valence electron of phosphorus, which is 5, and chlorine is monovalent atom, therefore 5, and no anionic charge, no cationic charge, divided by 2, which is 5, which implies again hybridization is sp3d2. Geometry is trigonal bipyramidal. Now shape is actually trigonal bipyramidal here. This will be shape. Now let us see here, phosphorus is the central atom. Draw 3 equatorial bonds in triangular form, and 1 up and 1 down. This will all be occupied by chlorine atoms. Now this is the structure of PCl5. 2 axial bonds and 3 equatorial bonds. This axial bond is slightly longer than this equatorial bond. In PCl5, how many angles? How many 90-degree angles are there? This angle will be 90 degree, this angle will be 90 degree, this is 90 degree. Similarly, this axial chlorine will form 3 90 degree. So in 90 degree, how many angles are there? 6. In 120 degree, how many angles are there? This is 120, this is 120, this is 120. 2 equatorial bonds की मरकता angle between से क्या होगा? 120 होगा. So 3 120 angles are there, and how many 180 degree angles are there? There's only 1. Okay, in case of PCl5, geometry and shape are same, which is trigonal bipyramidal. Now let us take one more example in which shape and the geometry are different. Third example is SF4. In case of SF4, sulfur is the central atom. So 6 plus 6 plus 0 minus 0 divided by 2. This gives, this is 4, not 6. So this will give 5 as the value of H, which implies that hybridization of SF4 around sulfur is sp3d. Geometry will be trigonal bipyramidal, but the shape will not be equal to trigonal bipyramidal. Let us check the shape of SF4. Now since the geometry is trigonal bipyramidal, I'll draw sulfur as the central atom and the structure of trigonal bipyramidal. 4 fluorine atoms, let these 4 fluorine atoms be in this position, and this remaining bond will be converted into lone pair. So the lone pair occupies the equatorial position, or another possibility is sulfur is the central atom, trigonal bipyramidal. Now in this case, Let us keep the lone pair at the axial position, and this will be occupied by fluorine atoms. Now let us check which structure is the correct structure of SF4. Now for that we need to check the repulsions. Stability is inversely proportional to repulsion. Higher is the repulsion, stability of the compound will be less, or lesser is this repulsion, higher will be the stability of the compound. So now let us check here lone pair bone pair repulsion. Actually, by VSE pair theory, which is valential electron pair repulsion theory, lone pair repulsion, lone pair repulsion is greater than lone pair bone pair, which is again greater than bone pair repulsion. So this is the maximum or largest repulsion, lone pair repulsion. And in this case no lone pair repulsion is there, because this is bone pair, this is lone pair, this is lone pair bone pair repulsion. So since there is only one lone pair, there is no lone pair repulsion. So we need to check lone pair bone pair repulsion at 90 degree. Remember, just count the number of repulsions at 90 degree or less than 90 degree, because at 120 or 180 the repulsion will be less, so that can be easily neglected. Now let us count the number of repulsions, lone pair bone pair repulsion at 90 degree. Since this is an axial equatorial position, this is 90 degree, equatorial and the axial bone is 90 degree, this is 90 degree. So how many 90 degree angles are there? This lone pair and bone pair is 120 degree, so we will not include that one. So lone pair bone pair repulsion 90 degree is only 2. In this case, since this lone pair is at the axial position, this is 90 degree, this is 90 degree, and this is 90 degree. So lone pair bone pair at 90 degree is equal to 3 here. So repulsion is larger here, so this has lesser repulsion, therefore this is more stable, this is less stable. So we can cross out this structure of SF4. This has higher stability, therefore shape of SF4 will be, this structure is seesaw. So shape will be seesaw. I am taking one more example here in which there are atoms other than monovalent atoms. The fourth example here is carbonate ion. For example, carbonate ion, carbon is the central atom here. So 6 carbon has 4 valence electron, 4 plus monovalent atoms. There is no monovalent atom here in this case, so M will be 0 here. Anionic charge is 2 minus 2, this will be added. No cationic charge is there, so this will give the value of HS3. Therefore this implies hybridization is sp2, geometry is trigonal planar, shape is carbon around carbon, trigonal planar geometry is here, trigonal planar. So 3 oxygen atoms will occupy this position, therefore geometry and shape will be same for this particular ion, because no lone pair is left on carbon atoms. We can write here a double bond. Remember, we cannot write 2 double bonds here because carbon cannot make 5 bonds, since it cannot have expanded octet. because of the absence of d orbitals. So shape will be trigonal planar only. Let us take one more and the last example for this video. Fifth one, for example, XEF4. Now XEF4 is a compound of xenon. Xenon is a noble gas element, group 18 element. So number of valence electron of xenon is 8. So V is 8 plus F is monovalent, therefore 4 plus 0 minus 0 divided by 2. This will give 6 as the value of H, which implies that hybridization is sp3d2. Geometry will be same as this, that is octahedral. Shape will be different. Now for shape we need to draw the structure. Xenon as the central atom. This is the octahedral geometry. Now let us keep the fluorine atoms here at the axial positions, and these two remaining bonds will be converted into lone pair. Now we can draw another possibility of this compound. Xenon is the central atom. Now if I keep the two lone pair at axial position like this will be fluorine, fluorine, fluorine. This is just a possibility we are discussing. Now in this case lone pair repulsion is at 180 degree, but here in this case whether these two are at how many angles? 90 degree. This is 90 degree, or if this lone pair is here, then also this will be 90 degree, and the lone pair repulsion at 90 degree will have maximum repulsion as given by this postulate of Vesper theory. So this has higher repulsion, implies stability will be less, this will be more stable. So this can be neglected, we'll choose this one. So the shape of XEF4 will be, without these two lone pair, only the bone pair, this will be square planar. Square planar. Thank you guys. Please like the video and share this to your friends, and please subscribe my channel, and please also comment whether you like the video or not, and if you have any suggestion please write in the comment box below. Thank you.